Hello, my name's Aaron Gassmann, and I'm a professor in the Department of Plant Pathology, Entomology, and Microbiology at Iowa State University. I conduct research on insect pests of corn, and today I'm going to be talking about how to rate corn roots using the 0 to 3 node injury scale. So I have a number of roots in front of me here. If you look, this is a rootstock from a corn plant that's had very little feeding injury. One of the interesting things to notice here is just the structure of the nodes. So nodes are produced sequentially by the corn plant, starting with the earliest nodes here in the center and then out from there. And when rootworm larvae are feeding, they're going to be feeding on whichever node is actively growing at the time. So the 0 to 3 node injury scale is based on the number of nodes that are pruned, or the proportion of nodes that are pruned. And a node is just a circle of roots here that goes around the plant. And we're interested in those roots that are pruned to within 1.5 inches of the base of the plant, or in cases where the roots are growing above ground, 1.5 inches of where that root enters the soil. And so to score a plant for rootworm feeding injury, we begin with the outermost node and we inspect it to see if there are any roots that have been pruned. Now, some of these roots are going to be actively growing, so they may not be 1.5 inches long yet. Remember, I mentioned that these nodes grow sequentially. So it's important to recognize what rootworm injury looks like. And the corn rootworm larvae are a tunneling pest, so they're going to enter the root tissue and feed within it. And they'll often cause the root to become discolored. So for example, here's a root that has had some feeding. It hasn't been pruned yet, but you can see the discoloration. And if you look closely, you'd also be able to find a few holes where the rootworm larvae have entered the root tissue. So this is a rootstock with very light feeding, and as we go around these nodes sequentially, you'll notice that all of these roots are more than 1.5 inches long. So this would be scored as having very light feeding. Basically, the way the scale works is if an entire node is pruned, that would be a score of 1. If less than a node is pruned, it would be the proportion of roots that are pruned. If just one root is pruned, it's 0.1. If there is some pruning, but nothing within 1.5 inches, that would be a 0.05. And if there's light scarring, which is the case on this rootstock, it would be 0.02. So this is a good example of what a rootstock looks like, but has very light feeding injury. I'm going to set this aside, and we can contrast this with a rootstock like this one, and maybe I'll bring the other one up for comparison. So you can see here, basically very, very light feeding injury versus a heavily pruned rootstock. So here you can see that multiple nodes have been pruned within 1.5 inches, either where those roots enter the soil, which for these later nodes, you'll see the change in coloration, right? So the green on these roots indicates that they're above ground. There's some chlorophyll there. And then once the roots enter the soil, it'll be more whitish in appearance. So we know then that all of these roots are pruned within, basically to the soil line, so well within that 1.5 inches. This next node is also completely pruned, as is the node after that. There's one root that's a little bit longer, but would still not really reach that 1.5 inches. I like to have a landmark on my hand, so I'll measure a joint in a finger. In this case, it's my thumb. That's 1.5 inches long, and then I can just use that as an easy reference when I'm going through if I ever have any questions. So this would be an example of a 3.0, so meaning that 3 nodes have been pruned. One thing that farmers will often wonder is, well, what does that mean in terms of yield? And studies at University of Wisconsin as well as University of Illinois looked at many years of data on root injury and yield, and they developed regression analysis, basically mapping out that relationship, and found that one node translates to about 15 to 17% reduction in yield. Injury like this were occurring across the field, the farmer would be looking at somewhere between 45 and 50% yield loss, so it would be very substantial. It gets a little more challenging maybe when the feeding injury is not quite as severe. So here we have to take a more careful look at what's happening. This latest node here, you can see these roots are still developing. They may kind of have the appearance of being pruned, but typically what's happening is because they're so exposed to heat and desiccation, they simply don't develop very well. So these roots are not pruned, but just simply because of environmental damage, they didn't make it into the soil. So we'll exclude this one from our rating. But now when we move to the next node, you can see it looks somewhat different. Oftentimes the ends are going to be pretty jagged. That's from the rootworm tunneling in. And again, if you look closely, you'll also see holes where the rootworm larvae have entered and exited the plant. Moving along here, again, we're going to consider this entire node pruned. So this is one node of pruning. Then we move to the next node. We'll peel this one back. We'll examine the next node. Here again, as I go around, I'm noticing that every root, with the exception of perhaps this root here and this root here, has been pruned. So then the question is, well, what proportion of the node is that? So to figure that out, we need to get a sense of how many roots are in a node. So we can go around and count them. So this has a total of 12 roots. So 10 out of 12 are pruned. So then we just need to think about, well, what proportion would that equal? 10 out of 12 roots that are pruned, or this would be about 0.8, 80% of a node. So adding that to the previous node, we get 1.8 nodes pruned. And then we move to the next node, and here you can see these roots are fed on and they're scarring from the rootworm feeding injury, but it's not pruned quite as extensively. So as we look at this next node, see very little in the way that's actually pruned. And this, again, is a function of the rootworm larvae feeding on the node that is actively growing. So when the larvae first hatched, they were likely in this node feeding. They were small, early instar, so they caused quite a bit of scarring and some pruning, but not to within 1.5 inches of the plant. Then as they continued to grow, this next node began to develop. They moved on to it and pruned it completely back, and then subsequently moved to this node and pruned that as well. So this rootstock would be rated as a 1.8. So still a substantial level of feeding injury. Typically we say for farmers, they would like to maintain nodal injury below either 0.25 or 0.5. That's going to be a function of, management costs and value of corn. Higher levels of injury would indicate that they should adjust their management to try and reduce that injury. And we'll talk a little bit more about that later in the segment. I can go through a few more roots for you here if you'd like. Again, when you have something with a lot of injury, it tends to be pretty easy to rate because it's going to have, several clearly pruned nodes. So again, here's another example of a heavily fed on root stock. And you can see that this plant too, because it had so much pruning, it had lodged in the field, so basically the plant had fallen over. And then it develops this characteristic gooseneck morphology where it's trying to right itself. And so you see that the stalk is very bent compared to something like this. For these heavily pruned ones, the rating is pretty easy. So I'll look around here, one node, and then I see the second node is pruned. And then as I go around these later nodes, there's actually a little bit more than 3 nodes pruned, so the scale only goes up to 3. So this would be rated again as a 3.0. Okay, so now on to something a little bit more challenging. As you look at this rootstock, you'll notice this latest node, some of these roots appear to be kind of truncated or stunted in their growth, but I would not attribute this to rootworm feeding. This is more likely where the root had hit the soil and then has simply quit growing. Those can be somewhat challenging to rate. I think the key thing to look for is the presence of tunneling, feeding scars, and then also how do the earlier nodes look? If there's a lot of feeding and evidence of a large rootworm population, then that provides some indication that maybe those rootworm were moving up and feeding on these later nodes. But here I think, many of these roots made it into the soil and some probably just hit soils that were dry and hard and fairly hot, and they weren't able to grow. So as we move down then to the next node, here we can start to see some feeding injury. And so these roots are scarred, and you can clearly see that they've been pruned, but not anywhere within 1.5 inches. So they would not be counted as pruned. But then as you move along here, okay, now we're seeing some roots that have been pruned. So there are several here, and then again a few more that have not been pruned. So the thing to do in terms of scoring for root injury is simply to figure out, well, how many roots are on this node, and of that, how many have been pruned. So we'll first count just the total number of pruned roots here. So that's 1, 2, 3, 4, move around 5, 6, 7, 8, 9 roots that have been pruned. And then the total number of unpruned roots, we have 2, 3, 4, and then 5. 14 total roots on this node, and 9 of them have been pruned, so 9 out of 14. So again, just have to think about what proportion that is, about 0.65. Keep track of that, and then go on to the next node. And here, there's again evidence of scarring, but not much in the way of actual pruned roots within this node. So this one would be rated overall as 0.65, and would be, you know, a little bit higher than a farmer would typically want to have in their field, but what would, you know, often be encountered especially in a continuous corn situation. We can rate one more root, again trying to pick one with a little bit more intermediate level of injury, just something that's a little bit more challenging. We'll go around this outermost node. I'm not noting anything that's pruned. And then we get into the next node. You can see evidence of pruning, but not within 1.5 inches. So none of these roots would be scored as pruned. And then as you get into the later nodes, again, you can see the scarring on the root tips, and so they're pruned, but nothing pruned within 1.5 inches. So this would fall into that 0.05 category. And if you want to stick around for extra credit, we can do one more root together, starting at the outermost. And just, if the roots are, after you wash away the soil, if you keep them in water, it makes it much easier to break back those roots. Because basically what you want to do is go through and just look at these nodes sequentially. So here is a root. You can see, I say, oh, it's more than 1.5 inches long, but if you look where the coloration changes, you can see it entered the soil here. So this would be considered pruned. So we have one root on this node that's pruned, and then we'll continue around. These roots likely just didn't make it into the soil, but was not caused by rootworm feeding injury. So, and then if you look later in the rootstock, they're actually pretty clean. So there's not a whole lot of feeding going on here. One thing that you'll see often with roots is this regrowth. And so if the root is damaged, or if it is pruned and someone comes along later, a few weeks later, and digs those roots, they'll notice a fair amount of regrowth. When we're scoring for nodal injury, we're only interested in the nodal root. So that regrowth may go for several inches, but it doesn't count in terms of whether or not a root is pruned. It's just where did that nodal root grow to. For example, here with this pruned root, you know, maybe if I were to kind of pinch this regrowth together, I'd say, well, maybe that's a little bit longer than 1.5 inches, but that doesn't count. We're just interested in where that nodal root stopped growing. For this rootstock, there's one root that's been pruned by rootworm, and that's always scored as a 0.1. So it doesn't matter how many roots are around that node, it's just simply a 0.1. So this would be a 0.1. Some rootworm feeding, but well below, you know, where a farmer would need to be concerned about it. Yeah, so I think something along the range of about a dozen plants would be good. And, you know, it depends on the question. If they're just trying to get a general sense, I would say as widely spaced as possible. If they have a particular area where maybe they're concerned about, you know, how well the rootworm management is working, then maybe they want to target their sampling there. One thing to keep in mind with corn rootworm is that those eggs will be somewhat patchy within the soil. In other words, there'll be areas of high density and some other areas of low density. It's important to sample, I would think, at least eight roots to try and get a sense of what's going on. 12 may be better, especially if the area that's being sampled is larger. Dig up the rootstocks in the field and then bring them back here, and they'll basically have, you know, all of that soil still held within the roots. Just simply place them in large bins with water and let them soak for a few hours, you know, something on the scale of 6 hours, maybe up to 24 hours. Would not want to leave the roots in water any longer than that, because they'll start to decompose, and then it gets very difficult to figure out, you know, what is rootworm injury versus just decomposition. So they could be soaked for up to a day, but no more than that. And then we have a root washing station where we'll take hoses with smaller nozzle that generates a fair amount of pressure, but nothing on the scale of like a pressure washer, just pressure from a municipal water line. And we'll use that to simply wash away all of the soil that remains. And then we generally will put the roots back into water. As I mentioned, if they're not desiccated, they're a little bit easier to rate. It's a little bit easier to peel those nodes back as you're going around. But even if they dry out, they can still be rated. It's just sometimes a little bit more challenging. It depends on where someone lives, because further south the rootworm are going to hatch earlier, and as you move north that hatches later. Here we are in central Iowa, and here I'd say on average the rootworm are going to hatch around the 1st of June, and adults are going to be emerging around the 1st of July. So when we think about digging roots, we would like all of that larval feeding to have been completed. And those adults are basically going to emerge from the soil throughout the month of July, meaning that while the first larvae may have finished feeding in late to mid-June, there are other larvae in the soil that are still feeding well into July. So we basically wait until we're at peak rootworm emergence, which for us would typically be around the middle of July. So that means that the vast majority of rootworm larvae that are in the soil have finished feeding. You'll know you're at peak abundance if you look at the field and you see roughly equal proportion of male and female rootworm, if you know how to tell them apart. The males tend to emerge first, and when that abundance equalizes, you're pretty much at the peak of the emergence curve, or slightly past that peak. And so that's a good time to dig roots. So we'll start our root digs during the second half of July and dig roots into August. If a person waits too long, it's still possible to rate the roots, into late August, but one thing you'll run into is regrowth of that root tissue, those fine roots, especially if a root stock has moderate levels of pruning, say around a node to a node and a half. There can be quite a bit of regrowth, and that then makes it hard to find those nodal roots. Sometimes they'll be down within a mat of fine roots, and it takes quite a bit of time to pull those roots apart and figure out where the nodal roots are and assess how much they've been pruned. Sometimes you'll see that soil factors will influence how the roots grow. In particular, compaction can be an issue. If the soil where you're digging the roots has a lot of compaction, you may notice that the rootstock, instead of being open, and this one actually shows an example somewhat of what compaction looks like, it starts to become flattened. So basically what you have here with a plant like this is the roots are growing in the opening made by the furrow. So the soil is compacted, and so the roots are preferentially going to grow here. As compaction becomes worse, they'll become more and more compressed, and until you almost have these nodes kind of flattened on top of each other, growing in a straight line down that furrow. It's scored in the same way, but it just becomes challenging because it's a little bit more difficult to recognize the structure of those nodes. Remember, we're interested in the proportion of roots within a node that are pruned. The person has to be able to go through and figure out where that node is, how many roots are in the node, and then how many of those roots are pruned. So that can create a challenge. One of the other challenges you might run into is that in some cases, these later nodes will be growing, and some, the position is variable, and it may be lower down, and there may only be a few roots that have developed in the node. And you can see this one, none of these really made it very close to the soil except for a few. And then what can occur is that there will be some pruning on those. But if one of these nodes only produces 2 or 3 roots and they're pruned, the question is how to score that. Would that be a 1.0 because every root on the node is pruned? Typically what I would do in that situation is I think about, well, how many roots are potentially in the node? So say there are 3 roots that are pruned, but there were 20 roots that could have grown in the node. So instead of calling it a 1.0, I would say it'd be 3 out of 20, or 0.15. And I think that helps to keep the ratings more consistent, because you wouldn't want to think about penalizing a plant just because it only had a few roots in a node. It's really how many roots could potentially be present in that node, and then of that, what proportion are pruned. One of the big drivers of rootworm abundance is the environmental factors. So you can think about population dynamics of corn rootworm as being affected by a few different factors. So one is the practices within a field, farming practices, and because corn rootworm requires continuous corn cultivation to complete multiple generations. Those fields that are in continuous corn are going to lead to larger populations. But overlaid on that are various environmental factors. And cold winter temperatures can increase egg mortality and contribute to lower abundance. Moisture in the spring is also a really important factor influencing survival of corn rootworm. So when those rootworm larvae hatch in the soil, they need to travel to a rootstock and begin feeding. And it's far more difficult for them to move through soils that are saturated. Heavy rains in the spring after planting can reduce the ability of the larvae, the newly hatched larvae, to make their way to the corn rootstock. They'll die along the way, and that'll suppress overall abundance. During dry years, conversely, that larval establishment tends to be much higher. And so dry years tend to be conducive to larger rootworm abundance. And also moisture stress exacerbates the effects of rootworm feeding. So that larval injury is going to have a greater impact on yield in dry years versus years where there's adequate or surplus moisture. Dry years are going to have larger abundance on average of corn rootworm, and also the feeding of those larvae is going to have a greater effect on yield. There's some evidence that sandier soils may be more challenging environment for the larvae to survive, and again because they're, I think, moving through that soil matrix to try and establish on the root tissue. But I always tell people, I think the key thing to keep in mind is that while environmental factors can have an influence, and there certainly are periods where there can be substantial suppression of rootworm populations because of environmental factors, someone can't depend on that. And it's really what they're doing within the field, specifically how much corn on corn is being produced. That's going to be the key driver of corn rootworm abundance. These are examples of roots that have been protected. You know, that insecticide is going to be present at planting around the base of the plant. It will be mobilized by water and move more broadly within the root system. It's a fairly narrow, you can see a fairly narrow zone of root protection. And as those roots are outside of where the insecticide is applied, or as the season goes on and the insecticide becomes degraded and diluted, protection is going to be reduced. So it's very common then to see root pruning when soil insecticides are used. The question is, what's the level of pruning? So can someone combine other management tactics such as crop rotation to reduce the overall abundance of rootworm in that field? You know, maybe it's 3 years of continuous corn instead of 8, so that when soil insecticides are used, they'll achieve a level of protection that's satisfactory. But one of the big benefits with the soil-applied insecticides is that it will increase standability. So the better developed rootstock is going to help prevent that plant from lodging. But there can still be root pruning and still, associated yield loss.